Welcome and congratulations to the class of 2022. Plus one member of the class of 2020. We invited, this is our first in-person ceremony since lockdown 2 years ago, or was that 3 years ago? 2 years ago. So we've welcomed back members of past classes to come graduate in person. A reception will follow our ceremony out in the lobby, and you're all invited to that. Also, graduates will be called by name to receive their diploma. Please come to the stage for that. And graduates, you may say a few words if you wish after receiving your diploma. And finally, we'll be taking, you're welcome to come up and take photos of your graduate as they're receiving their diploma. We'll also take some photos which we'll distribute afterwards. Graduates, you've completed a rigorous course of study and grown as scholars and more broadly as humans. You've completed Starfleet Academy, either the astrophysics or planetary science tracks, or some of you both, because you're gluttons for punishment. You've learned about everything from subatomic particles to the cosmic horizon, some 13.8 billion light years distant. But while you've accumulated a great deal of knowledge, the most important skills you have gained are that you have learned how to think critically and scientifically. You've learned how to approach difficult problems and how to learn on your own. You've embraced the discomfort of the unknown, that in science we disprove or support a hypothesis, but we are always open to revising our theories based on new evidence. Your skills make you much sought after in a wide variety of professions, including teaching, research, innovating, and developing policy. Beyond skills, as part of your liberal arts education here in the College of Arts and Sciences, you've gained perspective and insight into humanity's place in the universe. Astronomy is an age-old endeavor and a field that touches us all. You are now experts and ambassadors with a truly cosmic perspective. Congratulations. I'd now like to introduce our theater manager, Nick Conant, and graduate Allison Garskadden for the astronomy presentation.
Thank you, Nils. Hello, everyone, and welcome to the Fisk Planetarium. My name is Nick Conant, the theater manager here at Fisk, and I'd like to give another round of applause to Allison Garskadden, who will be running this show for us. She is actually going to be graduating this year as having been a Fisk student for a number of years, turning into a navigator, so she can actually control everything that you'll see on this dome. And she's currently back there setting us up for right here and right now. What you would see on the most glorious of days in Boulder, Colorado, that's what our dome is going to be representing for you. But I need to first welcome all of you undergraduates and graduates, beloved family and friends, staff and faculty, to the Fisk Planetarium. Now, I need to grab our laser pointer because there's something that is key here as we show you a little bit of what your undergraduates and graduates have been learning in their degrees. First would be, if you follow my laser pointer, this is the most important thing in astronomy. We call it up. And if you follow my laser pointer from up to down, you'll find our exit sign. Should there be any concern to leave the theater, please don't go straight for the exit sign when it gets really dark in here because, well, it's not over the actual exit. It's over a wall. So should you need to leave, please choose to go to the right of the exit sign. All right. Well, now that we've been introduced to up, what else is there in astronomy? Well, we're going to take a brief tour of the universe and show you a little bit of what your graduating student has been learning throughout their career here at the University of Colorado Boulder. So we'll begin in the traditional fashion with implementing a sunset. Allie, let's watch what our beautiful sunset would look like tonight with the crescent moon in tow right behind. The sun will begin to set a little bit north of west, and as it sets, we'll begin to see the glorious stars come out. You'll see the crescent moon right over the mountains. Now, one reminder is please no flash photography while it's this dark, because it will ruin our night vision. Now, as we look up at the night sky, this is the furthest you can look in any direction. You're looking at a sea of stars. Our sun is just one of these stars. This is how astronomy begins for many of us, by looking up at the night sky and thinking about how small you feel compared to the vastness of the cosmos. You try to look out in between the stars to see the Milky Way galaxy sometimes nestled among them. For generations, our ancestors looked at these stars. They made stories. They tried to find meaning in the cosmos from this perspective, from the ground, from the earth. In only the last half century or so have we actually been able to leave our planet. In fact, it was only a little over 50 years ago that we finally journeyed off our planet and visited the moon itself. But now astronomers regularly send telescopes and satellites out into space to do more astronomy. Sometimes Earth science looking back down at the Earth, and sometimes to look further into space. Here we are getting a view of our planet. Back down here you can see the weaving of all the city lights. There's Boulder and Denver, the Front Range. You are right now right down there. Now this is more of Earth science look back down at the Earth. In fact, in this journey, we're going to travel further away from the Earth. So, as we look back down, we'll be maintaining our view on Earth as we continuously back away. Now, one thing that immediately grounds us is how seemingly far away the moon is, but actually it's the closest neighbor to us in space. It is about 1 light second away. And if you have any questions about some of the terminology I'm using in this presentation, just ask your graduate tonight over dinner. Now, a light second is the time it would take light to journey from the Earth to the moon. And in that case, it's about 1 1/4 light seconds, meaning that an astronaut on the moon would only be able to receive a radio transmission after about 1 second after it left the Earth. Now, we actually get to celebrate something this semester that we haven't got to celebrate really any other semester, is the successful launch and deployment of the James Webb Space Telescope. After 2 decades of waiting and I suppose 15 years of delayed launches, we finally have actually launched and deployed the James Webb Space Telescope, or now named the Webb Space Telescope, which is out 4 times further away than the moon. It actually managed to go out there and be deployed and is almost the coldest thing humanity has ever made, at least something that is so far away, it's almost as cold as deep space. Here's a little video of it deploying itself. It went through so many maneuvers, and this is probably why they delayed launch for so long. We really wanted to make sure this worked, and in fact, every single thing worked flawlessly. Or I should say, nominally. The James Webb Space Telescope is replacing, no, it's not replacing. It's sort of augmenting the array of telescopes in space. You see, the Hubble Space Telescope has been dutifully serving its role as the premier astronomy telescope for the last 30 or more years. Finally, the James Webb Space Telescope, which is actually much larger than that, you can see each of the golden mirrors of James Webb is actually the size of the Hubble telescope primary mirror, just about. And so finally, this telescope will be out there at what we call the Lagrange point and actually be in a sort of semi-stable orbit around our sun, able to peer far away into the universe, into places that we have currently blurry pictures with Hubble will actually be gorgeous views of astronomy with the Webb telescope. Now, as we continue backing away from the Earth, we'll actually see the whole solar system come into view. We have the sun at the center, and we're still centered on the Earth here, this blue orbit. We've got Mars, Jupiter, Saturn, Uranus, and Neptune. Now, another event that has happened throughout your careers here at CU is the landing of the Perseverance rover on Mars. Here's a selfie it took, or not quite, but this is actually just a animation, a little cartoon of it. Perseverance is about the size of a SUV. It's quite a large Mars rover, and yet it'll be doing the most advanced studying of Mars from the surface that we could hope for in the current era. It will try to uncover the history of life on Mars, if there is any, or at least learn a little bit more about the red planet that we all have the blues for. Now finally, as we leave our solar system, we'll recall that our sun has 8 planets, 9 if you count Pluto. But there are so many stars in the night sky, we've wondered about the possibility of life on other planets around other stars. In fact, we have now put up a data set revealing stars around our galaxy that have confirmed exoplanets. In just the last month or so, we have announced that we have officially discovered 5,000 stars that have confirmed planetary systems around them. 5,000. That number has grown by an order of magnitude in just the last few years, last decade or so. And we'll continue backing away from our solar system and get a perspective on all these colored dots that will reveal to us just how many of these planetary systems we have found, exoplanetary systems. And if you look over your left shoulders, you'll see the Kepler Space Telescope has been viewing into a specific concentration over here, looking at a number of planetary systems outside, beyond our solar system. We're now flying so far and so fast that we have exceeded the speed limit of light, and we will journey far beyond the realm of stars to leave our Milky Way galaxy. We now believe that each star in our galaxy contains at least one planet, probably more. At least that's what our current science is revealing, is that planets are much more ubiquitous than we thought. And we believe the Webb telescope will help us discover even more, maybe even directly observe some. Our whole Milky Way galaxy contains some 200 billion stars. Our sun, just one, already lost amongst this deep spiral galaxy. And thank you, Ali, for labeling it for us. Right there is home. We don't live in the center, downtown Milky Way, and we're not quite on the outskirts. We're about 2/3 of the way from the center. A Milky Way is about 100,000 light years across. So from this vantage point, we are currently tens of thousands or hundreds of thousands of light years from our sun. As we back away even further, we'll reveal to you the rest of the universe. In fact, our Milky Way galaxy is quite a large galaxy compared to its nearby neighbors, the large and small clouds of Magellan. And it has another nearby neighbor, which is off the dome on the other side, the Andromeda Galaxy. And you'll see that on these massive scales, galaxies are pulled together by gravity into these large clusters, these clumps. Here we go. There's Andromeda. Now, for those of you who are familiar with the Powers of 10 video from 1977, they stopped around here in the universe. And we're going to pause here for a moment and make these galaxies a little bit more grandiose, because, in fact, every dot you're seeing here is not a star. It's not a planet. It is a galaxy with about 100 billion stars in each one. And we can give them all little pictures. Let's see if we can jam them up even brighter. See, this helps me because we are currently orbiting right into, I believe if you back out a little bit more, Ali, I think we're orbiting right into the Virgo supercluster, in which was the first confirmed, yep, it's right behind us. I think, Ali, you nailed it. Wow, straight into the Virgo supercluster. Oh, no, it's this one down here. Well, this is part of it. Right inside, at the heart of that, is M87, inside which was the first picture of a supermassive black hole. Quite a dazzling picture that you may find familiar. In fact, the team that took the picture you're about to see actually is making another announcement on May 12th. Very nice. Here we go. Yes, this one. And you're seeing some of the contortions of the magnetic fields added into this picture. Now, if you want to know more about this picture, you definitely should ask your graduate about that, but I can tell you that our entire solar system would roughly fit inside of this black region here. The supermassive black hole is indeed enormous. It's about 66 million light years away, and it's about 4 billion times the mass of our sun. 4 billion suns combined into a black hole at the center of the most massive nearby cluster of galaxies. Now, this is just the tip of the iceberg, because we're going to now really blow your mind as we pull even further away from the Earth, further away from our local supercluster, and zoom out to see the nearest 1 million or so galaxies. I've completely lost track of home. It's a good thing our loved ones are here with us. They help ground me. For some of you, your careers may advance into revealing a little bit more about the universe in this perspective, because the realm of galaxies is not entirely revealed yet. We have numerous blank spots. And as we pull even further away, that will become very apparent, because some of the most distant galaxies haven't even been imaged yet. With the Sloan Digital Sky Survey, we have been able to look north out of our galaxy and a little bit south out of our galaxy, but we haven't imaged the entire universe yet in all directions. There's still a lot of work to be done. In fact, on this scale, we're now looking at nearly the entire observable universe. A view of galaxies that extends all the way out to what astronomers call the cosmic microwave background, or the CMB. It's the most distant view that we can have of our universe. It's as far away as astronomers can look before they can see no further back in time. The light from this modeled pattern of black and red is some 13.8 billion light years old. The differences here between the blue and the red is only about 1 part in 100,000 in Kelvin. It shows us that the universe was the same everywhere you looked in the beginning of the universe, and slowly those darker regions of blue would pool to form the galaxies that you currently live in. And those galaxies forming stars and planets. This is the view of astronomy we have to show you, and hopefully some of us graduates and undergraduates will be able to take more data and help refine our view of astronomy to have even more intricate, precise measurements of our universe. Now, as we continue our journey, we're going to zoom back in now and try to find where we were. Give us that sense of perspective. Where is the Earth in all this madness? Lost amongst some possible 20 trillion galaxies in the known universe, each with about 100 billion stars. As we dive back in, we'll fly past all those galaxies we left behind. And see that our view of astronomy is currently self-centered. We have no other place to view the rest of the universe from, only our own perspective. To look out at the cosmos and try to measure it, to know more about itself. And by doing so, learning a little bit more about ourselves. In fact, I think one of the most profound things about astronomy is being able to look at the universe and being able to look at ourselves as being a part of that universe. And as we zoom back into the Milky Way, I want to remind us of a famous image that was taken by the Voyager spacecraft as it left our solar system. We'll gain that perspective, but first I just want to bring up that image while we stall here on the Milky Way. That being the Earth, what is now known as the pale blue dot. I'd like to read for you Carl Sagan's musings on this pale blue dot. And we'll remove the image as Ali zooms in and we find it amongst our sea of stars. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you've ever heard of, every human being who ever was lived out their lives, the aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor, and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. We'll see that dot as we continue to zoom in. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there's no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. It's been said that astronomy is a humbling and character-building experience. There's perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. I'll leave you with those wise words of Carl Sagan because I feel like the last few years have been tumultuous enough for us all. It's important to remember our true position in our universe. If everyone on Earth knew this message, perhaps the world would be a better place. Congratulations, graduates of 2022. And thank you, Ali, for navigating us through the universe. Thank you.
Thank you, Ali, and thank you, Nick. That was wonderful. And I feel small. So, I next want to introduce our Associate Chair for Undergraduate Studies, Professor Seth Hornstein, who will call up our graduates to receive their diplomas.
Thank you, Professor Halverson. Before we give out the diplomas, I have one more honor, and that's to call up our undergraduate speaker, Destry DeWitt.
Hello, everyone. Thank you for the introduction, Seth. So I just wanted to share a little bit today about my experience, which I know my fellow graduates have had at least somewhat of a similar experience. I'm originally from Austin, Texas, came out here 4 years ago, had never been to the city of Boulder before, and just dove right in, really enjoyed it. I bet everyone else could say the same. I worked for the LA program for 2 years, which is the Learning Assistant program, which is where I got my feet wet with teaching and discovered that I wanted to do that for the rest of my life. I worked for the department for 2 years as an LA and an LA mentor, and after 2 years decided to focus more on research. I got a position at LASP, which is the Laboratory of Atmospheric and Space Physics. Really cool place. Worked there for about a year on a project, and I'm now working there still on a new project doing instrumentation. One of my favorite classes that I got to take in the entire department was observational astronomy, which was actually 2 separate classes. I know most students got to take it and really enjoyed it. The super long nights in the observatory, getting there at midnight, staying until like 5 a.m. Sounds not as fun as it really is, though, especially being next to this massive telescope that's actually just 100 feet away from us. I also got the opportunity to TA for the second observation class this last semester as a senior, and that was a very great opportunity. So I don't know if we can get this image up, but I wanted to share a question from our final exam in a class that I know a lot of us have taken. It's called Galactic and Extragalactic Astrophysics, where we learn about cosmology, the origin of the universe, the Big Bang, dark matter, and dark energy. And so, as you guys can probably tell, pretty hard to understand what's going on in this question. Not many of you, and honestly not many of us, could even tell you how to understand it or how we're going to use it in the future. But it was still very fun to learn about this stuff. And I bet they could say the same, even though some late nights for sure. So I just wanted to give a shout out to all of the graduates, obviously. You know, we've put in a lot of hard work, and these are definitely some of the brightest and smartest future astronomers that are entering the world right now. So give it up for them. And then just some, words of advice, which I don't really have many to give because I'm in their seat with them. But, some of y'all might have a plan moving forward right after graduating, maybe starting a new job or something. And for those of you who do have a plan, congratulations. For those of you who don't really know what's happening next, congratulations still. And I know for me, having professors like Seth and other really cool professors throughout the 4 years, never rule out teaching. It is a very rewarding experience. So with that, I say thank you and congratulations.
Awesome. Thank you, Destry. So my name is Seth Hornstein, and as the undergraduate associate chair, I'm pleased to be able to call up the graduating students in the Astrophysical and Planetary Sciences graduating class. Now, as you're likely or may not be aware, because of the size of our graduating class and the desire to use this amazing facility, we've split our commencement program into 2 days. So not everyone in the program will be called today, but don't worry, we'll call all of you. So students, when your name is called, please come up and receive your diploma from Dr. Halverson. Pause for a moment so your parents can document your accomplishment, and then you will have the opportunity to say a few brief words, if you wish, and then go down and take your seat again. Parents, feel free to come up as close as you want. It's a dark room. Don't be the one parent who gets that blurry, grainy photo of maybe your student graduating or your loved one graduating. Now, many of you know that for the last 22 years, only 2, we've been dealing with the various implications of the COVID-19 pandemic. And because of that, our graduation ceremonies for the past 2 years have been held virtually. This year, we wanted to give the opportunity for those who have graduated in the past 2 years to have their moment of glory and be recognized. So before we get to the class of spring 2022, it is my pleasure to call up Jonathan Lee from the class of spring 20.
Just want to thank Jeremy Darling, Zach Berta-Thompson, and Adam Kowalski for inspiring a formerly lousy student to do better. And most importantly, my parents and best buddy Jeremy for sticking by me. So thank you, everybody.
And we'll get to the spring 2022 graduating class. Students, your last task, I already assigned you, but your final last task is to line up along the back wall of the planetarium in the order that you currently are. Now, it's in the order that you currently are. Now, I have some explaining to do. Some of you eagle-eyed parents may recognize that we're not lined up in the normal order that you might expect your student or your loved one to be in. In 2018, there was a nationally recognized study out of the CU Department of Economics that found that students whose names are at the front of the alphabet tend to be recognized more and even have more success in life due to our tendency to alphabetize nearly everything in our world. From where you sit in the classroom, when you get up to go to the buffet, and yes, when you get your diploma. So today, to even the playing field for those folks who suffer from what they called alphabetic injustice, we're going to go in reverse alphabetical order. So with that, it's my pleasure to call up our first graduate, Amanda Wimmer-Flint.
Okay, cool. Well, I'll try to make this quick. Oh, that's so cool. Aww. Okay, well, first of all, thank you everybody for being here. My family included. Got my mom, Ty, and of course my sibling Ruby. Love you guys. We've got Dad and his wife Cynthia. I've got Grandma Donna, Grandpa Bushy, Grandma Marie, Grandpa Daryl, Abby, my best friend, and my Uncle Corey are all sitting in this room. Thank you. And for those of you at home, I know my Papa and Sue, Tyler, Katie, Riley, McGuire, Julie, Alex, Carson, Keaton, and Abby. Everybody, thank you so much. All of your love, energy, money, lectures, hugs, and support have made all of this possible. I really appreciate everything that you've all done for me, and I will truly do my best to continue to make you proud. I also want to say thank you to Jacob Matthews. Unfortunately, he can't be here today. I miss him so much, and he should have been here, but he's in our hearts and our minds. And I also have to say thank you to Fisk. Thanks to Nick. Thanks to all the staff. Allie graduating. That navigating was awesome. You guys have given me such a sense of friendship, and I really appreciate it. And then last thank you is to Connor at home. My dear beloved, I couldn't have done any of this without you. You have made all of this possible. So thank you, everybody, and Sko Buffs.
Elijah Shepard.
I just want to say, first off, how great of a campus this is, how many supportive people, professors, how many friends I had over the years. Obviously, my parents and my brother were a big part of my success here, but without the people here at Boulder, I wouldn't have gotten here, so that's all I gotta say. Love you, Mom.
Corinne Rowley, graduating magna cum laude.
Thank you, Seth. Thank you, Professor Hamilton. Thanks, Dad. Thanks, Lena. Thank you, my brother. He's taking an exam, so he's not here. And I want to thank my mother who died back in 2018.
Alex Raymond.
One more.
I work here. So people don't have to, Anyway, thank you to everyone that's here for me and has been here for me. I have so many mentors, not only in our APS department, of which I'm pretty sure I've taken classes with all of you, you guys included. But thank you to anyone who supported me throughout this whole journey, and looking forward to the next one.
Nicholas Ronnie.
I just want to say thank you to everyone who supported me throughout the years.
Anthony McKinnon.
Thank you everyone for being here and supporting all of our amazing graduating class. I'd like to say a special shout out to my parents and my sibling. I know without all of their financial and emotional support, I would not have been given this amazing opportunity. So thank you very much.
Patrick McCreary.
I'd like to thank my parents for their support and Dr. Mark Rast for amazing advising for 4 years. Thank you.
Spencer Lynch.
I just want to say thank you to my mom, my dad, and my sister for all their love and support.
Catherine Krebs.
Thank you to my family for all the support, and thank you to Dr. Mark Rast for caring. Thanks.
Chris Hauk.
I just want to say thank you to my family and all the great professors that I've had over these 4 years. Thank you.
Melanie Graham.
I'll just say thank you to everybody that supported me and to all the staff in APS that it's just been an amazing ride, and it's finally over for me. So here's what's coming next. Thanks.
Allison Garskadin.
Oh, okay. Yeah, obviously I want to thank my parents, my family, all the support from my friends. The support from counseling and psychiatric CAPS here on campus is amazing. And Amanda, I learned everything from you, so thank you. Oh, and Seth, my official mentor, which you have to.
Noah Farrick.
I just want to say thanks to my family and Sco Buffs.
Destry DeWitt.
I just want to thank my family, especially my grandma and my mom, my friends and loved ones, and all of the amazing faculty in APS.
Emma Davidson.
I just wanted to thank everyone in my life. This has been a very rough semester, and I couldn't have gotten through it without my family, friends, faculty. Thank you, Rast, for everything. Thank you, guys.
And my apologies, I missed my own notes. I forgot to announce that Patrick McCreary is graduating summa cum laude. Congratulations, Patrick. Now there's one more student who's receiving a diploma today that we would like to recognize. For that, I'd like to call up Dr. John Keller, Director of Fisk Planetarium.
Thank you, Seth. As the director here at Fisk Planetarium, I'm honored to make this introduction. Jacob Matthews was an APS undergraduate here at the University of Colorado Boulder, and a member of the class of 2022, and a beloved employee here at Fisk Planetarium for 4.5 years. Unfortunately,
Tragically, Jacob passed away in his sleep on January 1st, 2022. Many of you had him in your classes. He worked here at Fisk for 4.5 years as our ticket manager. And as we all know, we miss his loud laugh. We miss his philosophical questions that he always stumped us with here at Fisk every day. And we missed his kind and gentle giving spirit. Jacob had just a handful of classes left before he completed his undergraduate degree here in Astrophysical and Planetary Sciences and his minor in Political Science. Today, the APS department, the College of Arts and Sciences, and the University of Colorado System are granting Jacob Matthews a posthumous Bachelor's of Arts degree in astronomy. I know that if Jacob had been here with us in person today, he would have been overwhelmingly proud, both of his own accomplishments and also of each of you. He would be celebrating with you and with your next steps as you venture off into the coming years and decades beyond the CU Boulder campus. As a memorial and tribute to Jacob, we ask that you make the most of every moment that you have ahead of you on this pale blue dot that we call home. To live with honesty, integrity, and grace as Jacob did, and to always do your best, and to take time throughout to reflect on the precious gift that is our lives. Jacob lives on in our spirits, in our memories, in our actions, and in our intentions. Our hearts go out to Jacob's parents, his siblings, his wife Sheila, and their 1-year-old daughter Vela. Know that we are here for you always. I would now like to invite Sheila to come join us on the stage to accept the degree for Jacob on behalf of his family and loved ones.
I know that if Jacob were here, he would be so very proud of all of you for your dedicated pursuit of intellect. I also know that he would want you to know that if plan A doesn't work out, there's still B, C, D, even Z. Don't lose hope, because every animal has its own niche. I know that he'd want you to know that sometimes the world seems full of darkness and despair, but that we can choose to make it better, and that in every situation you can act with kindness and compassion, and you can ask yourself how you can be a light in that darkness. So, congratulations.
Thank you, John. And our hearts are with you, Sheila. With that, I'm proud to announce the graduating class of the spring of 2022. We'll do a formal group photo in the front of the planetarium immediately following the ceremony. Now, as you've heard, completing a degree in astronomy is no easy task. All of our graduating seniors should be proud of their accomplishments. However, we'd also like to recognize our students who were awarded academic scholarships this academic year. Since many of the winners of these scholarships are not graduating seniors, they were unable to join us today. However, this doesn't make their accomplishments any less noteworthy. Since we aren't presenting any of these awards today, please hold your applause until the end. The Perspectives Endowment Award was awarded to Jackson Avery, Mackenzie Dean, and Christina Lucas. The Ben C. Parmenter Scholarship was awarded to Junyu Chen. The Sherpan Seal Award was given to Olivia Blevins. The Susan E. Wesley Scholarship was given to James Baldwin and Anna Pesci. And the Theodore Snow Scholarship was given to graduating senior Spencer Hurt. Please join me in congratulating these students on their awesome achievements. And with that, I'd like to hand the mic back over to Professor Halverson to present our 2 graduate degrees.
We're now presenting recipients of Doctor of Philosophy. First, I'd like to welcome to the stage Professor Yuri Tumre, who will hood PhD graduate Lauren Matilsky.
First, a few comments about Lauren. He has taken on the challenges of figuring out what goes on within the sun, not just on the surface. The sun rotates, it bubbles away with convection in its outer 30%, and somehow builds pretty fierce magnetic fields. We've learned about many of these things because we have the ability to look at the shakes and shimmers of the sun called helioseismology, and from it we can figure out some of the large-scale motions and structures that are within the sun. And when it comes to magnetism, we can see it as sunspots and varying large-scale magnetic fields that cycle. And these are the things that Lauren has taken on in his research work, some using the available data, but particularly carrying out very large simulations using supercomputers, and maybe using some of the sort of champion number of hours to be able to accomplish this. NASA provides these machines that have 100,000 cores, and he's used sort of millions of hours to essentially simulate what may be going on within a star. Our very nearby star, we've heard that there are a few 100 billion other stars in our own galaxy, and there are billions of galaxies. So stars come in large numbers. So he's taken on a big job. He's done superbly with this, and now we'll proceed in a few months to go on to Santa Cruz, where he has a postdoc courtesy of the National Science Foundation. So there's a tradition of putting on all of these things. I feel are a little bit like medieval monks of some strange religious order. I'm not sure what we are, but welcome to the order.
Well, thank you, Yuri. And thanks, Brad. I don't know if Brad's here. I feel like he might have gotten the time wrong, because tomorrow's is 2 to 4. Oh, he's here. Hi, Brad. I just want to say thanks so much to Professors Yuri Tomre and Brad Heineman. You guys were the inspiration over the, I'll just say it, 7 years that it took to get this degree. And you really shaped my scientific perspective, I think, for life. I wouldn't have explored the problems that I got to without your guidance, support, and sometimes orders. So I'll carry that perspective with me wherever I go. And then I would obviously like to thank my parents. I think you're on Zoom right now. I don't know where the camera is, but I'll wave. And I dedicated my thesis to you, and I said, what did I say? To my mother, who taught me that work meant dedication and perseverance, and to my father, who taught me that work meant force times distance. And I really mean that. Mom, you showed me what a work ethic is, and that you can't just skate by. Even if you do well naturally, you've got to put in the time. And Dad, you knew about X-ray astronomy before it was cool, and you instilled in me the love of science, and I couldn't have done it without either of you. And then to the rest of my family, to everyone in my class, to everyone in APS, there's too many people to thank, so thanks everyone, and I will always remember my time here fondly. Thanks.
I'd now like to bring back to the stage Professor John Keller, who will hood our PhD graduate Elizabeth Butler.
Thank you again. I am pleased to be able to introduce Dr. Elizabeth Butler. I was not Elizabeth's primary research advisor, but I did get to play a part in her dissertation. Adam Kowalski was not able to be here today, unfortunately, to hood Liz, but wanted to just briefly introduce Liz and all that she's done here at APS. Liz, too, as Yuri said, studies the sun, but from the opposite direction. So rather than from the interior, Liz studied the surface of the sun using an instrument known as IRIS, which is a spectrograph that allowed her to probe the Doppler shifts, the velocities and directional motions of magnesium, iron, and carbon on the surface of the sun in active regions where the sun is flaring. Those flaring events and probing in that spectroscopic way allowed her to actually look at the directions that the flows were occurring to help us better understand flares. And confirm some of the models, one of the Fisher model and other models that we are using to understand flares. Liz also recognizes that she's part of an ecosystem of learning, and actually all of the world is focused on how we learn collectively. And so with me, she approached me during COVID spring, if I believe I was correctly, reached out, said, I would like to really understand better how the research to operations to research world works. And what does that mean? We have lots of researchers who work in academia, discovering things and learning fundamental core physics of the universe. And then we also use that in applied research to use it. And so one of the big one of the big goals and values of solar physics is to actually understand space weather and our sun, and to predict events that would endanger astronauts and actually even take out power lines in our world, and other technological issues in our world. And so Liz reached out to me to see if we could study and research and interview those space weather forecasters who are out there using the research that we do to better understand what their needs are and how we can better serve that community with the work that we do in our research world. And so I really appreciated her dissertation, which was both looking at research from a fundamental perspective of solar physics and flares, and also from the space philosophy from the space policy perspective of how we can do a better job of actually using that knowledge in our everyday life. Finally, Liz was very, very influential at CU Boulder in the production of many, many of our films. Dr. Doug Duncan had a grant from NASA called the Explorations Grant, which puts together 5-minute short videos about NASA physics. And Liz was influential in the script writing of many, many of those scripts and contributed greatly to Fisk and Fisk Planetarium, in addition to significant committee work that she's been involved in throughout all of her time here at CU Boulder. She's headed off now to a postdoctoral fellowship in Northern Ireland, and we're really grateful for everything she's contributed and excited to see her as she advances in her career. And I will now get to attempt the hooding as well. And actually, Yuri, the hoods are because the people in the Middle East in Oxford and Cambridge didn't have enough money, and they actually walked around with their hoods, so you could put pennies and other things into the hoods as you were wandering the streets thinking academically about various things. So, Dr. Liz Butler.
So since I'm the last one, I'm going to try and keep it short. I've said most of my thank yous already during my defense to most people who attended. I just want to emphasize a last minute thank you to my mom, who laughed at me when I'm musing that maybe grad school wasn't the right place for me. So thank you for pushing me to attend anyway.
So this concludes our program for today. I want to thank everyone for coming, particularly family and loved ones of our graduates. Congratulations again, and students, graduates, plus faculty, please meet outside the Fisk lobby doors. We're going to take a group picture right now. And just also to remind the rest of you, there's a reception in the lobby. The faculty and the graduates will walk out first, and then we'll meet you all outside in the lobby. So congratulations once again to the class of 2022 and 2020.